how I want it to be. So thank you, my dear friend, my mind. I feel I am one with myself, completely grounded, totally focused and concentrated. Shanti. Om Shanti.
Thank you, Ashima. Thank you very much. That we'll get started for today's session. I see few other attendees have joined. Is there anyone who's joining for the first time? If you can please respond over the chat window, that'll be great. Okay, I'm assuming you all have attended our sessions before. So today we'll start with a quick sharing some information regarding career progression. We'll talk about different programming languages and kind of development we do. And after that, Prashant will talk about serverless computing. What are AWS Lambda function? Why do we need them? Based on my experience in every AWS project, first choice is to use serverless computing because it's a cost saving, especially for workloads which are very transient in nature and very unpredictable. We don't want to be paying the cost for a VM running 24/7 when I know the request will be coming in only for a short amount of time, or if I'm using API gateway, then I don't need to have a server which is processing that logic all the time because I can run that code on demand. So serverless computing is nothing but function as a service. So we'll have Prashant talk more about it as well. So let's get started with what does a developer do? In our previous sessions so far, we've covered the various roles in IT. What are the different topics that we've been covering? What are the different roles that we typically cover as part of IT? And as part of that, different roles, last week, I think we talked about architects. What does an architect do? So today we'll talk more about what it is that a developer does as such. So let me quickly share my screen. You should all be able to see the screen now. So just a quick recap, we saw the different roles, what an analyst does, what an architect does, the different type of architects. And then today we're going to talk about developer. So the purpose of the developer is to write code and implement the design which an architect produces. So architect looks at the requirements, captures the key requirements, and then come up with a design. And the architect will create a design document which will cover all aspects of the design, where the data is, how it will be integrated with different systems, whether it's bulk data, real-time data, what is the source, what is the destination, and covers all aspects of the solution. And if there are any components which require programming, then developer would do that. Depending on the choice of the programming language, depending on the system which is using some component, accordingly, we may have developer who's a .NET developer. For example, if you have a system which is built in .NET, and we need to add more forms to it, or we need to add more business logic to it. Since the application is in .NET, we would need a .NET developer. If you are building a data science application which is processing the data, and we don't have any team, it's a lot cheaper and easier to get a Python developer because Python is the most commonly used language now. If you look in terms of the number of jobs, and the best way to verify is just type in Python developer, see the number of jobs that come up, versus type Java developer and see the number of jobs that come up. And you'll find, at least in US, the maximum number of jobs are in Python as well. But you might have another backend systems which is built in Java. So in that case, if you have to customize or do any changes, you would do it in Java. If you're working with Salesforce, Salesforce uses a language called Apex, which is very much similar like Java as well. Many times you're doing cloud. So cloud uses serverless computing. A lot of it is you get a choice. You can do it in Java, you can do it in Python as such. And most of the time, the default preferred language is Python. So strongly recommend those who wants to get into development or those who are students wanting to learn a programming language that is very commonly adopted, it would be Python. It's very easy to learn. You can learn it in less than a week as well. So we'll talk a little bit more about it as well. So what does a developer do? They do development. And after doing the development, they would actually unit test their code. And a good developer would also be typically connecting with some database, NoSQL or relational database, and then checking in the code, deploying that code, and that's part of the DevOps process. So last week we covered cloud formation, how we can set up a VM, and that will be part of the DevOps process as well. So it is implied that a developer understands what is DevOps, how does the process work, and because they are a critical link in that chain where they are checking in the code, deploying it, executing the test, and so on. Nowadays, every project that I've worked in, we build loosely coupled solution. Last week, we also covered loosely coupled. We gave the example of a train where you have the multiple coaches in a train and they're all loosely coupled. So you get that agility, you get the flexibility. And one of the ways to build loosely coupled system is to expose API. And the advantage, why we want another advantage is because when you're exposing these APIs, one of your system could be implemented in Java. The other system could be implemented in Python. But they are interacting through APIs, and that API definition, that is language agnostic. You can have an API endpoint, which is taking a JSON or an XML, but the way it is processing that JSON could be in Python, could be in Java, could be in any other language as well. Could be JavaScript as well. So that's how we can now make it easier to exchange data between different systems where you can have developers. One might be a .NET developer, another Python developer, and so on, as long as they're communicating through API becomes agnostic. A lot of these frameworks that come in, they use what's called as a protocol buffer, where you can have different programming languages consume the same functionality. So if you're building a product and defining a software development kit or an SDK for it, and you're using something like protocol buffers, you're making it easier for organization who might have Java developers or organization would have Python developers to empower them to achieve that functionality using a programming language of their choice. So the choice of programming language depends, what is an existing technology stack for which we are building a component, or an organization might say we're going to do everything in .NET, or they might say we do everything in Java. And sometimes it evolves. They might say we want to do everything in .NET. A new CTO comes in and says we're going to do Java. So I've seen organizations go both ways. They'll go from Java to .NET or .NET to Java. And after some time, they'll just give up and they say, okay, use both, whatever is existing. But I find more and more trend for adoption of Python. And many times the architecture team would also lay out guidance and have a say in it. But primarily depends on the application as well. It is Python. You can use Python as a functional programming language or as an object-oriented language. But previously, when we were doing a lot of it, was any project we had, we used to build and design it. And there was a lot of emphasis on the design of the system, which was implemented in some programming language. So we had a component model. You would use UML. and build a diagram to show what are the different components and how it works. Nowadays, because we are using API, so we think more in terms of services rather than thinking in terms of objects. So previously, if you were a developer, it was a must that you are object oriented. You see everything in terms of objects. You're writing a class called bank. Bank is an object, and so on. So now we should be reading in terms of services. So we have service-oriented architecture or service-oriented approach instead of object-oriented. But some of the concepts of the programming language, object-oriented programming language, remain the same, such as encapsulation, abstraction, and so on. So it's always good and sorry about that. It's always desirable and good to know at least one object-oriented programming language, such as C, C++, C Sharp, Java, or Python. In universities, they still teach C or C++. So if you are already learning that, that's great. It'll be very easy for you to learn Python or Java, but it's always good to have one object-oriented language. Nowadays, there's more trend. Instead of organizations building their own systems, they would want to use software as a service or use platform as a service capabilities. In addition, Microsoft is also pushing for no-code or low-code apps like Power Apps, where you have to do minimal coding, more configuration using YAML files. That way, it's easier to manage and maintain the application, and it's a lot cheaper because every time you write code, you have to test it. There could be bugs in it. There could be defects in it as well. So we want to make sure that we are, as an organization, they're spending less money on coding and they're just configuring that software application. So which programming language to choose? Well, it depends again on that application I said. But if you notice, if you're writing anything on the portal or in the presentation, it's very common to use AngularJS or React, write widgets in your web portal. And those are use JavaScript frameworks. So that's client-side programming. You're doing validation. You have a web form. That web form is capturing the data, but that data is not submitted back to the server as such. So there's a lot of client-side validation, which for years has been done in JavaScript. And now those widgets, which are loading on the client's Google browser. So it has fast weight, it's lightweight as well. So a lot of the presentation, if you're a UI developer, then you would probably need to know JavaScript for sure and know at least one of the frameworks such as AngularJS or React. If you're doing integration and you're using Kafka, then you might prefer to know Java as well. Or if you're using any ETL tool or any ESB, then good to know Java as such. But if you're using an API gateway, which is triggering a Lambda function, you can use a Python runtime and code it in Python as well. So it varies as well. But when it comes to data, SQL is a must. You have to know SQL. It's desired that as a developer, you know at least the basics of SQL as well. So I'll quickly cover in my next slide, talk about what are the other languages. So mainframe systems, these are like old systems. Not many are found in India, but a lot in US still exist. They were written using COBOL. Nowadays, a lot of organizations, they moved away from mainframe. So the demand for COBOL skills is extremely low. Yet in some universities, they will cover it because those professors, they know only COBOL, so they will teach COBOL. But there are new languages that are coming up as like Scala, Ruby on Rails, Haskell, Golang or Go, Julia, and so on. So typically, if you're doing data processing, for example, you're using Databricks, then you could use either Python, you could use Java or Scala as such. If you're doing data science or you're doing a lot of data analysis, again, Python is very popular. A lot of data scientists would use R as well. I haven't personally used Ruby on Rails or Haskell, but I've seen organizations, some of them use it, but most common it's Python and R. But some organizations do use Ruby or Rails and Golang. And the reason why these new languages come up is because they are meant for executing or running the code in a distributed environment where you have a lot of concurrency as well. So Golang was invented by the Google team. They use it internally as well. So it gives you, it's supposed to give better performance than Python. But it takes time for the market to adopt a programming language. So right now, maybe Go will catch up, but right now Python still remains the most commonly used and sought after skill set. Uh, Financial systems, they tend to still use C, C++. So that's why in universities, they will teach that language as well. And the reason they teach that is because from a computer science perspective, if you are creating a new database as such, or if you are writing a new operating system, then you're going to not need that abstraction which some of these new languages provide, but you want to go more deeper down, not to the assembly language, but a little bit higher than up, where you're in control of how to manage the memory and so on. So that's why these financial systems, they will want to go more low level, have that control, and they'll use C or C++ as well. So those are the different programming languages that are there. As a developer, you would need to use that. That's all I had for my session today related with career guidance. Any questions so far? Okay. We'll move on to the next topic for our session, of where Prashant will talk more about serverless computing. So I would strongly recommend that you understand what is serverless computing. Please do ask questions. We'll be monitoring the chat as well. Again, no question is stupid question. You heard me say that many times. So please do ask questions so that you can get most out of this session. And if you have any questions from the previous sessions as well, related with career guidance, or have any questions about career path, please do ask as well. With that, Prashant, if you can share your knowledge and tell us more about serverless computing, that'd be great. Thank you.
Yeah, hi everyone. Thanks, Mukesh. So let me just share my screen. Let me know if you are able to see my screen. I hope that should be visible now. Okay, cool. So let's start with the agenda for today. And before actually we start, let me just give an introduction or overview what we are going to cover today. So welcome all. So today we are going to discuss more upon serverless computing. What actually is serverless computing, and what are the various serverless services that is provided by AWS, and we'll cover one of the serverless services today, which is Lambda functions, and we will see what Lambda functions are, how we can write them, and how we can solve various business problems or use cases through them. Then we are going to do a couple of uh, uh, we'll write some of the functions ourselves, and we'll try executing them and see how they are solving our various use cases. We'll do a very simple example, and then we'll move on towards a bit moderate, and then try to do a little advanced example later on in the section. So what actually is serverless computing? So serverless does not mean that there is no server. So that would be a wrong definition to explain. But what actually serverless computing means is that you need not manage or launch the server yourself. If I were to tell you that if you want to execute a Java program, okay, then what is the prerequisite that you need to execute that Java program? You are going to tell me that I will provision a Java environment. I will set up a Java environment on my operating system, and then I will be able to launch or execute any of the Java programs. Okay, so when you are executing your program on your own configured environment, on your configured operating system, then you are also managing your operating system as well as you are also handling your program or function, whatever it could be. Is my audio proper? Is anybody else facing any issues with audio? Okay, so fine. Dimakar, you might want to rejoin it. That might help you. So just try if that helps you. Okay, so to move ahead. So yeah, I was on Java program execution. So when you are launching your own Java environment and you're executing your Java program, that becomes two responsibilities for you. You have to manage your program as well. Also, you have to manage your operating system or your server, whatever it could be. Then what is basically serverless? So as you look into this figure, which I'm showing you right now, this it basically says server farms managed by cloud service provider. So here I'm talking particularly about AWS. So you see that there I'm showing you a lot of CPUs. So which means that you don't have to purchase you don't have to purchase any server on cloud. So here cloud will provision servers in the background. They will manage all the servers for you. They will provide all the runtimes that you need. For example, you need a Java runtime, you need a Python runtime, Go, .NET, or any available runtime that you need. The cloud service provider is going to manage that server for you. You just need to write your function. You just need to write your program, and you need not worry you need not worry about your deployment of your server, about the deployment of your Java runtime, about the version of Java runtime, whether it would be 7 or 6 or 9. You just don't have to worry about this thing. So now, if I show you the next slide, which is this. So basically, all the cloud service providers have huge, large scale server farms. Like you can literally understand the meaning of farm. Farm means just like of agricultural farm. A cloud service provider has a farms of servers, like many servers which can contain thousands and millions of vCPUs. Okay, so millions of vCPUs, out of which like all of those managed by AWS. And what you need to do is you just need to write your program and set up on cloud. Whenever that program needs to be executed, that will go to a particular server which is free, which has some bandwidth at the moment. It will get executed and will come back with the output. So your program got executed, you got the output that you wanted to get, and you still did not provision your environment or nothing. It just went to the right server which had the Java runtime and came back with the appropriate output that you wanted to have, and then you moved on. And like this, you saved a lot of efforts. First of all, you did not provision a server, and if you had provisioned a server, you had to keep it live for 24 hours, and then you would have to pay for 24 hours of charges for running that compute servers. And if your requirement was to only get your program executed a couple of times during the day, let's say a dozen of times, 12 times, then you actually saved a lot of cost, right? So what are various AWS services that are serverless? These are some of the services that AWS provides as serverless services. For first one being Lambda functions, then we have API gateway, then we have Elastic Container Service that helps you provision containers on AWS cloud, and Elastic Kubernetes Service that helps you orchestrate the containerized environment on AWS cloud. What are the advantages of serverless services? So it offers you a greater scalability. First of all, So, as I mentioned, that serverless is not about a physical server that is running in a background. It is about a complete farms. There could be millions of servers that are running together, connected with each other in the background that are managed by AWS. You don't have to manage those. You don't have to worry about those. So even if your function is taking a lot of time, it needs huge resources, then it will automatically scale and demand the required capacity out of those servers, right? So it will automatically scale because there is no limit. There are millions of servers in the background. But what if you had a single server in your environment that was executing Java, and your Java program, if it demands more capacity than that server can actually provide, the server is going to crash, right? Because uh, 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 like many times the websites crash because the website is demanding more potential, more capacity than what is actually provisioned in the background. So in serverless, there is no fear of getting crash because it can easily scale up to any level because that is serverless. There are millions of servers running in the background. Then it is more flexible because you don't have to worry about a lot of things. It simplifies. You just have to focus on your program and just leave everything on the cloud service provider. Quicker time to release. So as you're only focusing on your program, you have to automatically save a lot of time because you are managing only one aspect, not two. And when you write the program, and you deploy it, it immediately goes to the required infrastructure in the background, gets executed, brings the result back within the shortest time span, and provides you. So that solves your business use cases on very much on time. And the greatest advantage of the serverless is that it offers you all of these three at a very reduced cost because you are not paying for 24 cross 7 cost that you had to pay if you had to provision your own server. Okay, but uh, if your use case was such that you only needed an hour of compute to get your program executed, or let's say a couple of hours, let's say 4 hours of compute to just get your program executed and just manage your business use cases, then why would you provision a server yourself that will run 24 cross 7 and accrue you a cost of 20 hours extra? So that is how by adopting serverless practices, you can actually save 20 hours of cost per day, and that is going to become like around 600 hours of cost you're saving every month. So that becomes a huge number, right? Yeah, so now let's look at what is AWS Lambda. So like any questions so far from any of the previous slides? Then I can easily move ahead with the Lambda thing. Okay, if there is any, we'll definitely be taking up during the later section as well. So feel free to uh, put in your questions. So Lambda is a serverless service that that provides you code execution as a service. So code execution as a service means that you write your code, give it to Lambda, and it is the responsibility of the Lambda service that it will get it executed for you. Just like we go to a we give input to an industry, and that processes that input, whether it could be food industry that processes the food grains, and then ultimately we get the output. So it is a similar thing that you are just giving the code to the Lambda, and then it is getting executed in the background. You don't have to worry. You don't know which server it went to, and it will just go to the right server wherever it will find the right capacity. It will get it executed, bring the output to you that you can utilize going forward to into and integrate that output into various use cases and solve your business purpose. Lambda actually offers you some of the runtimes that I've listed out here, and there are even more than these. So it offers you runtimes for Node.js service, .js. Then we have runtimes for Java, Python, Go, Docker, Yeah, so Govind, Lambda is going to deploy your code. It will help you execute your code, and you just need to write your code in the Lambda service, and that is all. After that, you can simply deploy, and that is what we are going to look into our labs today. Okay. Yeah, Lambda is one of the microservices, in fact. So that is very true, Gaurav. Lambda is considered to be a very good part of microservices that actually helps establish microservices architecture in the background. That is also one of the things that can help you develop or migrate from monolithic to microservices. Okay, so just allow me a minute. Uh, yeah. So I'm back. Sorry about that. So yeah, today we are going to cover a lab which based upon this model. So we are going to deploy a few Lambda functions which will give provided appropriate role that will have appropriate access to communicate to interact with other service, which is S3 storage service. And it will have accesses like it can create a storage bucket, it can put the objects on the storage, and then it can write some files to the S3 storage service. And then we are going to perform some of the tasks using the Lambda functions. Yeah, so now I think it is time that we play around with Lambda. So I think I will now switch over my screen to the AWS console. Now let's go to the AWS console. Yeah, so now I am on the AWS console, and now we are going to do a couple of labs that will showcase you more about like what is Lambda, how you can use it, and how you can integrate or solve your various business use cases using Lambda. So you see, like right now my Lambda dashboard is basically empty. There is nothing at all here. And here there is a section of functions. And using this create function option, you can create your appropriate function. So let's start with the hello world function. Like whenever we learn a new programming language, the first thing that we do is to write a hello world. Similarly, while today we are talking on Lambda, let's create a new function that will deploy a hello world application for us. So there are three options basically here: author from scratch. If you want to deploy your application from scratch, your program from scratch, you can use this. Otherwise, you can use predefined templates as well for generic scenarios. So if you go to the blueprint, then there are some of the generic scenarios already listed here that you can use. So we can find our use case here, which is Hello World Python. So I will select the Python one. Now I need to give my function a name. I will call it a hello world function. I am going to use an existing role that I already have, which is this one, Lambda to S3. And this has all the appropriate permissions, like this role will grant this particular function ability to read, write, and copy objects, right? And even, uh, yeah, copy, write, read, and list access to the S3. Now, I have not written this code. This code automatically populated because I am using a predefined template from blueprints. So this hello world code automatically printed, which is a 12-line code. So now I will create the function. And now I have other options for my functions available here. So The first one is code. Then I have a test section wherein I can test my function that I have created. Then there is a monitoring section. So right now, all the monitoring metrics would be 0, 0. There would be nothing because we have not executed our Lambda function even single time. Then there are other options here. Configuration. You can set up your configuration for Lambda functions here. There are some options like you can define your permissions. I already have permissions granted through this role. Then we have destinations, so environment variables. So if you're familiar with writing programming language, you must be knowing what environment variables are. So these are some kind of environment like variables that you define in program, but rather than hard coding them in the program, you want to use them securely. So that is why there is a different section here. You can use your environment variables by creating them here. Then you can create tag. You can even associate your Lambda functions to a VPC. You can even define like monitoring. If you want detailed monitoring, you can even enable that here. And then we have concurrency. You can even customize the concurrency. And then there are, I think there was one thing that I wanted to show. Yeah, this one, general configuration. So if I will edit this, there are a couple of important parameters that you can play around. So memory. If your function is going to use more memory, then you can provision more memory here. Right now, the default is 128 memory. So our hello world function definitely does not require huge memory. So we are good to go ahead with 128 memory size. Then ephemeral storage, I think it is good. Ephemeral is a kind of integrated storage that comes up directly to your associated with your function. Timeout. So maximum timeout for a Lambda function is 15 minutes. Any Lambda function cannot get executed beyond 15 minutes. If it is taking more time, it will fail. So you can define your timeout here if it should take some specific time. Otherwise, you're good to go ahead. So now let's play around with our hello function. Let's see. So yeah, I will show that. So now to execute this function, first of all, we need to do a test configuration. So let's define our test configuration, which will be hello world test. And let me give a custom value here, hello world, and let me save it. Now, if I will click on test, it will execute this function for me. So now, as soon as I clicked on test, it is showing me my response, which is hello world. And then here it is sharing the function logs from which is showing all the details. Value 1 was hello world, which I edited. And then it is showing me it took 1.82 milliseconds. And so Lambda bills you for the round of time. So 1.82 rounded becomes 2 milliseconds. So it will bill me for 2 milliseconds, and then it out of 128 MB memory, it consumed only 36 MB of memory. So this is how we did a hello world. Now let's move to a little bit moderate example, wherein we will create a new function which will create a S3 bucket for us. So let me create a function. Let's create a S3 bucket via Lambda. So here, now just pay attention. Now, as you were asking, somebody was asking about choosing your own runtime. So here it gives you that opportunity to select your own runtime. So right now, there are a couple of options like .NET, Go, Java, Python. So I will select Python 3.7 for now. Under permissions, I will grant my existing role Lambda to S3. I will also showcase you this role and all the policies associated with this later on. And then I will create this function. So now I have my function created, but this code is the default code. This is not going to work for me. So I have my code ready here, which is this code, which is there to create a S3 bucket. I will wipe off this code from here. I will paste my own code, and just to explain you a little bit about this code. So I am importing JSON libraries and Boto3 libraries. So which I am going to use in my function below. And Lambda has an important component which is known as Lambda handler. So Lambda handler is a method which basically deals with all the events in the background. So this is the function that is the main function in the program that will basically manage all your program in the background. So here I am using the S3 libraries pulled in the client variable, and I'll be through which I will be creating this particular bucket which will have this particular name, and this particular bucket will have public read permissions. It won't be a private bucket, it will be a public bucket, and I am going to create this bucket in Asia Pacific South region, which is Mumbai, I think. Okay, so now first of all I need to deploy this function. I cannot test it unless I deploy it. So if I'll test it, it will ask me to deploy it. So but before let me just deploy it first, and then configure the test event. Let me give this create a S3 bucket test. Let me save and let me now test it. So it is running in the background. Yeah. So now it's telling me test that the response is null, but it has not given any error here. It took these many milliseconds and it billed me for 2814 milliseconds. So now let me go to the S3 portal and check if that bucket is created or not. Yeah, so if you look at this, I have my very first bucket. The name that I had given here was this. And I have my bucket created here, which is public and which uh, does not have anything here. So it says publicly accessible. So at least I was able to create my S3 bucket with the help of a Lambda function. Okay. So with the help of Lambda functions, you can even connect with other AWS services internally, and you can solve business case purposes. Like for example, you want to create buckets on demand. You have some POCs or tests going on, and you just want your all the test data to be written to some test bucket by automatically creating that whenever the test data is getting generated. So you can use such programming and write your own programs, develop your own programs for such use cases, and then you can deploy it. Now we have successfully created a S3 bucket. Now we are going to write some content into an S3 bucket. So let's come back and let's deploy a new function. Now again, I will name my new function write content to S3 buckets. I will choose Python 3.7, use an existing permissions, and I will create the function. Now, don't worry, I will be sharing all of this code with you as well, so you can even try at your end. So now I have some code available for writing to S3 bucket. I will wipe off this code. I will put this code here. So again, this code looks similar, does not have much difference. The only thing is here that I will be placing this particular section to a file, and that file with the name of customer ID 5151 with a .json format will be created in an S3 bucket, which will have this particular name. So let me see if this particular bucket is already existing or not. So this particular bucket is already existing, and right now I already have this file here. So I will delete it from here. So now I don't have any other file here. I just have this folder which will have some other random data. So now at this location, I'm going to place this file. So now I will deploy it again, and then I will test it. I will have to create a test event which will write content to S3 test. Let me just save it and then test it again. So now again the response is null, but we will have to validate the response by going to the bucket. Let's refresh here. Yeah, so you see we have this file available now, which is a JSON file and which was updated on November 27 at this particular UTC time, which has 87 bytes of data. Let's look at this file. What all content does it have? Yeah, so as you can see that all the content that I had shown you is very well there inside the file, and that is how even I was able to write to an lambda through an lambda function to an S3 bucket. Okay, so this is also one of the good thing that you can utilize going forward. So I'm just trying to show you various use cases that can be leveraged when you are working with Lambda. So S3 is just one service. We have 200 plus services available on AWS cloud that you can integrate with Lambda and can act. We have CloudWatch, we have uh, EC2, we have Secrets Manager, we have RDS that can be integrated with Lambda as well. Now let's perform one last example here, wherein let's solve a business use case. So for example, let me open a paint. So now let's create two buckets. One would be this, one would be this, and let's assume that I am a media customer. Okay, I am into media processing and all that. So I have billions of, let's say millions of JPG and PNG thumbnail images coming my way for editing. Let's say I have taken this contract from some of the companies that they will share me uh, their thumbnail images like JPG, PNG, which could be very huge images, let's say 10 MB or 20 MB of images. And then it is my company's job to edit them, compress them to the required size. So like I should be able to convert those 10 MB images to, let's say, 10 KB images, and then my purpose is fulfilled. So here we are going to create, we may not be able to do this item, but what we can do is we will create two buckets, and based upon this use case, we'll try to move objects from this particular bucket to an other bucket by using triggers. So as soon as you get an object uploaded to this S3 bucket, the Lambda function will automatically identify that object, do the processing, move that to this particular bucket and delete it from here. So that would be a complete atomic operation that we're going to perform now. Let's come back to the function. So guys, are you able to follow up with me well? Can you do a +1? If you are able to follow up what I'm trying to explain, all of you? Okay. Yeah, good to know that what I'm trying to explain is reaching all of you. So thanks for the positive feedback. Yeah, let's move ahead. Let's create another function that is solve our business purpose to which will have edit and move objects from one S3 bucket to another. I will select Python runtime again, which will let me take Python 3.9 this time because my code might require Python 3.9. We'll select this one, existing, create Lambda function. Then I have this particular code which will do the migration for me. I will wipe off this code, put this here. Now all this code is also 50% same thing going on. My Lambda handler is there. So here I am defining my bucket. It will pick up. So my bucket name would be this. So my bucket name is going to be this, which will be my source bucket. Then this is going to be my destination bucket, which I am going to create on the go. So these won't be there. If you look at here, I think my buckets are already there. Source and destination buckets are already there. So yeah, these bucket will be there. Then you see I am running a loop here, which will identify all the objects in the bucket, and based upon the count of the objects, it is going to run a loop. And in that loop, it is going to copy all the files and it will paste them in the destination bucket, and then at last it is going to delete them all from the source bucket. So we are going to perform this kind of business use case today. So let's proceed ahead. Let me deploy it. And before I deploy it, actually, let's look at our source and destination buckets. If we have anything within, okay, my destination bucket has a lot of items within. So let me delete them. So that got deleted. Let me come back to my source bucket and see if there is any item. There is none. Okay. So I have now created my Lambda function. But what I want to do is, let's, before I test it actually, now let's do a different thing. Let's add a trigger here. What is a trigger? Let's explore what does a trigger do. So let me add a trigger. So if you go by the literal meaning of trigger, which means if one thing happens, then automatically the second thing triggers, right? So here I will not press the button of the Lambda function to execute it on my click. Okay, what I would do is I will rather choose a trigger operation in the background that will initiate my Lambda function. So let's choose a trigger source. I will choose an S3 as a source. I will choose my bucket, which will be my source bucket, this one. And I'm choosing event type. Like what kind of event do you want to run in background that should trigger the event? So I'm selecting all object create events. So all object create events means even if you're putting the objects, you're deleting, you're performing any object operation on S3 bucket, that will trigger an event and it will automatically initiate the Lambda function. So I acknowledge and then I edit. Configuration on the same bucket cannot share a common event type. Okay, then I think I might need to delete my bucket first. And let me create another bucket, which I will call as bucket sequence 001 version 001. Let me copy the name and put it here. Let me deploy it again and then choose the trigger again with the same settings. So finally, I now have my trigger here, which means you see why my function is in the middle and not in the starting, because first my S3 will trigger, then only my Lambda will get executed. So which means now if I will come to this particular bucket, as soon as I do any object operation, right now the bucket does not have any object. So when I will upload any object here, the Lambda function will automatically get triggered. And what it is supposed to do, it is supposed to copy the object from here and to take the object to the different bucket, which is this particular bucket, and paste it here and then delete the object from the previous bucket. So then let's try to perform this operation here. So let me add a particular file here. Let me go to the downloads. Let me choose this particular file. Let me upload it here. Okay, so now I have uploaded my file here. Yeah, so as soon as I uploaded my file is no longer here. Okay, where did it go? So let's try uploading a different file again. And you see the performance. It it did not take much time. As soon as it got uploaded, the background Lambda function executed it just like a rocket ship. So it is that fast. Even when you're writing a program at a separate location and you do not know at which server in the background it is going to get executed, even though it is so much fast that it is triggering the execution within milliseconds. Let's try putting some different, let's try uploading this object and upload it here, close it. Let's refresh it again here. So any new person would be surprised and might feel that his objects are not getting uploaded. He would misunderstand that. But what is happening is our Lambda function is getting executed in the background, but he won't get to know that because there is no visibility of that thing here. How we can identify that? If we'll go to the monitor section, there will be some charts here. So under invocations, we need to enlarge it. And right now it is showing one invocation only, but actually it takes some time to reflect here. So it might take 2 minutes or even it can take 5 minutes, depending upon the background refresh. So meanwhile, it is getting updated. Let's look at the destination bucket. Here is the destination bucket, and you see that both the objects that I uploaded there have been successfully migrated to here. Now let's assume that if this file had been of 10 MB size, okay, so now within this particular program that I have written for copying section, you can develop a section in the middle which will do the processing for you. For example, I'm not sure what is the command here. So here you can do processing of your objects that will compress, edit, reduce, or do any operation that you want to do. And then once that processing is completed, it will successfully move them to a destination location. And then from there, it can be further utilized. So I hope you were able to catch up with the idea that I was trying to explain you. Now let's come back to the section here, do a refresh again. Yeah, so now it is telling that we had two, let's even customize it to 5 minutes. It's not showing anything in 5 minutes. Let's go with the 1 hour. Yeah, so now it's telling that we executed our functions twice. So that is the correct thing because we uploaded two objects. We don't have anything in the logs, but I think I was able to explain you very on how we can like implement our various use cases using the Lambda functions. We created four Lambda functions, starting from the beginners to moderate, and then we performed a use case, a little advanced one. So I think you were able to understand that. Any questions on any of these Lambda functions from your end? Easy to instance on runtime. I think that should be possible, but that is not an ideal scenario, Govind. Uh, that such scenarios are generally not implemented because launching an EC2 instance from Lambda won't won't help you much actually. So you can use CloudFormation, you can use AWS CLI commands to launch an EC2 instance, but Lambda function is something that might not be a very productive approach around that area. So Pratiksha, you were asking about the role. Yes, I should explain you what the IAM role that I was using is doing in the background. So let me show you all the role that I was using. So I was using the Lambda to S3 role. And if you see here, I have a couple of policies that is attached to this role. So first of all, this has I have given S3 full access. If you look at the full access, which means it can do any operation on S3, then automatically this particular policy overrides these and these, because again, these are S3 rules only. So all the create input operations are integrated here only, and all the operations that I'm even using, get and delete object, also fall within this access only. So I can do anything on S3. Then to come on this remaining, what I'm doing is I have other accesses to basically configure logging, but that we are not doing right now, so I can still avoid this one. So basically, as part of my this role, what I have privilege to, I can do anything with the S3 storage, so that I have access to, and that is what I am doing. And you were asking about execution role, so you can create your new role, or you can use your existing role here, and then you can just add permissions from here. You can attach policies, existing policies. You can create your own policies that you can attach to the Lambda functions. So can I have more questions on Lambda functions or concept? What is Boto 3? Boto 3 is just like library, like you must have, like I believe most of you must have programmed in C, C++ or Java during your college or during a professional time, in your professional life as well. So there is this thing include lib, include maths.io, and in like that include thing is basically library. So Boto 3 is again a library that is kind of helping us execute, like let me open up a function. So Boto 3 is an AWS custom library which I believe is that is helping us uh, running our S3 operations. So with the help of Boto 3 library, we are pulling in our S3 like we have access to all the S3 operations that we can perform. And then during the later section in the handler, we are performing all our S3 operations using those by referencing to that particular library. Is Lambda a constructor in C++? No, definitely not. Lambda is an AWS service, so it has nothing to do with C++. If there is some terminology with Lambda in C++ that I'm not aware about that, sorry about that. But this Lambda is an AWS product, AWS service that helps you run your code. So that should be different from what you are mentioning, Dipankar. Any more questions on this? Okay. So if like If there is any question from other folks as well, you can let us know. Otherwise, we still have some time. We can cover other services as well. We may not be able to do practical, but still I will be able to guide you through at least the concepts. Okay, so seem to be that there are no questions from anybody else. So I think in the interest of time, to benefit most of this time, let me explain you more about containers. So can I know like how many of you in the audience are actually aware what containers are actually and how containers are revolutionizing the IT world? Any idea about containers? If yes, then do a +1. If not, then put a no at least, so that I will be able to accordingly, I will be able to explain to all of you. Any idea about containers, Docker, containers, Kubernetes? Anybody heard of any of these items? Okay, so far I've got one response, which is yes. And what about others, those who are remaining? Okay. Okay, Govind has heard about Kubernetes. So to summarize, most of you have not even heard of containers. So the lab may not be possible today, but at least I can give you a good idea about what containers actually are. Because we have some time today, let's utilize that time to understand what containers actually are. So let me open Paint. So let me go to 2000, and then when during the when the IT industry was in its previous uh, like during the 2000, what kind of server we used to use in IT world? It would be a huge physical server. And this huge server is only able to deploy one application only. You cannot deploy more than one application on this particular physical server, which is as huge. And to get this particular huge server, you might you probably might have to wait for at least 20 to 30 days during that time. I'm talking about 2000. Okay, so now we have a technology that is known as VMware. So can I have +1 if people in audience know about what VMware is? Anybody heard of? If you know, do a +1, otherwise do no, so that I am able to appropriately explain you. Okay. So there is 50-50. Most of you, like many people know, but many people still don't know. But still, I will try to explain you what VMware is basically. So VMware comes with a, just a minute. So this was a this was basically a limitation that even if you are purchasing a huge physical server, you will only be able to deploy one application only, and still that is going to take you 20 to 30 days. Then there comes a company which is known as VMware Technologies. This comes up with a solution that you purchase a huge physical server, there is no problem in that. But what this company developed as a technology was that out of this huge physical server, you will be able to deploy, for example, out of this physical server, you will be able to deploy many virtual servers inside. So when I talk of virtualization, when I talk of virtual servers instead of servers, so which means that you can deploy n numbers of virtual servers with the help of VMware in that same huge physical server. But then that becomes a virtual server. So right now I had one server, one application. Now I have one physical server, but within that one physical server, how many virtual servers are now I'm now able to create? Like at least just to give you a rough idea, 3, 4, 5, 6, 4, 5, 6, 7, 42. I am able to create 42 virtual servers out of a physical server. So that is just a rough idea. You can like in real IT world, you can even provision more servers. You can even create 500 servers. So just to explain you on a roughly on a standard note, I'm taking this count. So this becomes a virtual server, which is known as virtual server. Virtual server, you can deploy your own operating system, which could be Linux or Windows or Unix or anything. Solaris, HPUX, etc. This one can have Windows, this one can have Linux, this one can have Solaris. So you can deploy 42 operating systems, like different operating system on different machine. But that was not the case here. If you have one physical server that will host one operating system, and that one operating system can only host one application. So VMware came up with an advanced technology that revolutionized the IT world of using physical servers. So now, if I go to 2010, 2010 to basically 2015, or maybe still even I can take 2020. So during this 10-year period, most of the IT infrastructure was running on VMware. They had physical servers in the background, but ultimately we were creating virtual servers out of this physical server, and where we were deploying our operating system, and then we were deploying our custom applications. So here we are able to deploy 42 operating system over which we can deploy 42 applications. So which basically solves a huge problem. Okay, now let's now let's understand what containers are. So yes, each virtual server will have their own virtual IP addresses. So which means if there are 42 physical virtual servers, they will have 42 virtual IPs. See, how the IP distribution process is not manual. If you must have heard about DHCP, Dynamic Host Configured Protocol. So it is the responsibility of DHCP server to allocate an IP address to each of the servers that is within your network. So even if your network is virtual, it does not matter. DHCP's responsibility is there. It is going to fulfill it. Now, what is container? So right now I talked about the VMware virtualization, right? So this is virtualization. Out of one physical box, I can create n number of virtual servers. Okay, so now what is containers? So in 2012, there comes a technology, Docker, that becomes revolutionizing for IT world, and that comes up with a concept of containers. What containers are? So like before going to IT world, let's look what containers actually are. So if I'll come to the browser and if I will type container, then let's see what comes up. See, if you know what shipping industry is, then you must be knowing what these containers are. You must have seen these containers on trains, on trucks, on ships, getting loaded and getting transferred. So what are these containers actually? So see, there are n numbers of containers on this ship, but each container might have a different environment. For example, if you were to ship food items to Saudi Arabia or Dubai or UAE, you would need a different container. You would need a cold storage container. Okay. But what does a container provide? Container provides a ready-made environment within. It will have that capacity of providing cold storage to the food items that are going to travel overseas from India to Saudi Arabia, because these countries generally don't have that much of agriculture, so they have to export or import required things, right? So that terminology comes from the actual container world. Then, yeah, then containers provides you a ready-made environment. So that is the first thing. Then containers are micro. How they are micro? Because they are not consuming the entire ship. If you look here, these are containers are micro because you're not randomly putting your stuff on the ship. You are organizing them in forms of containers. So let's say you have food items, then you have containers for food items that will be separate. Then you have a lot of electronic items. Let's say you have smartphones, you have TVs, televisions, computer monitors that are also going to travel across to different countries. But then you will have a different container for that use case, which will provide a ready-made environment to safely and securely transfer those objects, because those are like screen items that can get scratched or destroyed easily. So those containers will ensure that they have proper environment that will support those items, products, and they can easily travel from one location to another safely. Right. So containers are designed in such a manner that whatever they are going to host, that should be hosted in a safely and secure manner and should have the environment within that is going to suit that. Okay. So now what Docker container came up with? Docker container came up with a technology that said, okay, out of one physical server, VMware is helping you virtualize the physical server into multiple virtual servers. What I am going to do for you is that within one virtual server, you can further virtualize it. You can create multiple containers in one virtual machine. So which means that this particular section, if I take it here, becomes a ship over which you have so many containers. Which means in this particular virtual server, now you can further host multiple applications in this environment. You can run multiple operating systems in this virtual server. So this is a journey. So now this is 2022. So in this journey of 20 years, of around 20 years or 22 years, you see how far we have come. First, the technology has gone subtle on the subtle level. So initially we had this physical server, then we had the same thing, but we created virtual servers out of this, and then in 2022 we have further gone more subtle, and we have gone within these boundaries as well. We have gone more deeper actually. So this is the functionality what containers provide, that you can even host multiple applications within a single virtual server. So how far are you all with me? Were you able to understand so far what I have been trying to explain you? Do a plus one. Okay. So Gaurav, to answer your question, one container will host one application, but as I said, that container is a micro environment. You can host many containers in a virtual server. Okay. So one container in a virtual, like if you can host 10 containers in a virtual server, that means you're hosting 10 different applications in a virtual server, which means initially you had to provision 10 virtual servers for 10 different applications that you can do in a virtual server. But this is just an explanation on the capacity perspective. When you're going to deploy real world scenarios, when you're going to deploy production scenarios, that might not be the same. That might involve a fault tolerant architecture where you will have to deploy your current application over multiple VMs that will be fault tolerant in the background, partially hosted across multiple VMs, so that if one virtual machine is not up for some reasons, the another virtual machine is hosting that application. So the good thing about containers is it is like use and throw. You all must have used those napkins, right? Use and throw. So if a container gets terminated, if a container gets killed due to any overload, you know, as soon as it gets killed, within a span of seconds, the another container would stood up. So your application will not have to face much downtime. But imagine if your virtual server is going down, if your virtual server is crashing, then at least your website goes down for 10 minutes. You It will take you at least 10 minutes to minimum to stand up the replica. But in case of containers, it will just take a couple of seconds to get a new container started, and your website will, or a web application will come up within a span of seconds. So that is what container is. And to explore more on containers, you can type Docker containers, and if you'll go to this thing, Docker's website, you'll be able to understand what is a container. So here there is an architecture that is shown here, which means that on a host operating system means that you have a one big operating system, one physical server, one virtual server, wherein if you install Docker, okay, after installing Docker, you can directly deploy your applications. There is no need to even deploy operating system, because each of your application will come up directly with an operating system pre-installed, and will be coming up with the environment that their application needs. So if it is in Java application, it will automatically have that Java runtime, Java environment, and the required operating system within. So that is one of the advantages with the application, with the Docker, that it also reduces your work. It gives you that capability to distribute your monolithic architectures to microservices. And Docker is one of the background supportive component that helps support the DevOps and the microservices architecture in the background. So would request you all to, if you can go through this, that will give you a good understanding, because Docker is something that has taken up IT world like storm, like anything. So now most of the companies are not provisioning virtual servers. They are not using EC2 instances. They are directly using containers. So on AWS Cloud, we have a service which is ECS, Elastic Container Service. Let me also take you through this service, wherein you can declare your clusters, you can create your container definitions, you can create your repositories. So here, as I already mentioned, that containers is also a serverless service on AWS. So it offers you both. You can even deploy using your physical server in the background, or you can use Fargate. Fargate is a serverless service for containers. So if I go with the Fargate, let me go to the next tab. So here it is just asking me for some details. So yeah, I think explaining all of you these things might go above the head. So it would be better to skip this for now. Yeah, so let me open the web slide and check what is the next item for the next session. So just to give you a quick overview about the next session that we are going to have, we are going to talk upon the trending development languages that are there in the market and which one should you prepare for if you're a student and even a working professional. And then during the next session, we will try to revise all of our items or services that we have covered so far, because we will be now closing our AWS series in the next session, and then we will be planning to move towards other sessions. We'll be planning and organizing other sessions for you. So then, even if you have uh, some queries related to all of that we have covered, or you want to showcase a lab around any of the specific use case which from any of the existing services that you have already covered so far during our sessions in the previous sessions as well, you can let us know. Otherwise, we'll do some random labs for you, and then we'll be closing these sessions for you. Now, any questions and answers from your end so far? And meanwhile, you are asking the questions. Please feel free to post in your questions as you are already doing. Let me also share you the feedback link for today. And please do fill up your valuable feedback that is going to help us improve. Sorry. I've pasted the feedback link in the chat box. Please do take out your valuable time and do submit the valuable feedback. So that is going to basically help us improve. Okay, so as we might not be able to do labs around Kubernetes because that is that might go very high level, but we can have a basic lab on Docker. We can basically do a lab wherein we can deploy our Docker container and see what is how a Docker containerized application works versus how a application deployed on a general or a normal standard virtual machine works. So we can explore the difference between both. So that is something we can do. So Dipankar, you can use, there are software development kits provided by AWS that you can integrate with Virtual Studio Code by downloading that. And you can, as a developer, access the resources of AWS without going even to the console. So that you can do. So Sindhu has asked how to do lab. So Sindhu, you will have to create an AWS account. If you have not yet created, just create a free tier AWS account with your credit card or debit card. You will get access to 1 year's some services for 1 year, and there is some quota to that. Do be cautious about those as well. You can use the AWS free tier account to basically explore and learn about the various AWS services and do some labs, do some project work, explore, do some POCs. So you will have to create uh, a, AWS free tier account for that. So if you want to, so Kedar, you want to set up self-hosted container system. So just go ahead with by deploying an EC2 instance, use Amazon Linux AMI, Amazon Linux 2 image, and then just deploy container. You can just install container there and you can start using it. If you have container background, you have some knowledge how you can set up containerized applications, then you're good to go ahead. And meanwhile, other audience, please do fill up the feedback form. That is going to help us improve, because now we are going to plan up new sessions for you. So please do fill in. So if there are no more questions, can we connect applications from other platforms to AWS services? There are ways to that, but uh, based upon my knowledge, you can always set up VPNs, tunnels, if that is something outside to AWS. And by setting up VPNs, you can securely connect your applications from other platforms to AWS services as well. And nowadays, we are also following hybrid cloud models. So some of the cloud like Azure, Microsoft Azure, and AWS have a lot of services that are directly giving those integrations in form of plugins or like that. So you can directly use that as well.
And I'll add to that as well, Prashant. So another way is if you exposing your functionality as an API, you can host your API on Azure and you can consume it in AWS and vice versa as well. So that way you can have a system to system interaction using APIs. And in that case, it's really agnostic. Doesn't matter. It could be on the same cloud. It could be anywhere else as well. So that's another way you can connect application using API. So it depends, what kind of application is it, right? If it's using webhooks, so it depends. It varies as such. But as you were saying, yes, we can certainly use VPN to connect from on-prem applications to cloud. So various ways to do that as well. Another specific example I can think of is for organizations that are using a multi-cloud strategy where you have some applications in Azure, some in AWS, there is a need to exchange events between the two clouds as well. So in that case, there are new frameworks that are coming up that are providing that abstraction where it doesn't matter, your event is in AWS or it could be in Azure, but they will move as if it was one cloud. So there's something called as trigger mesh. And there are other serverless frameworks where you can write a function just like you are writing AWS Lambda. But then with the config change, you can select the cloud and then it could, similar capability in Azure is called Azure Functions. In GCP, it's called Cloud Functions. So by just selecting a config change, it will deploy that code in that particular cloud. Like even last week, we saw Cloud Formation. A lot of organizations, they use Terraform and they will provide that abstraction. So by using those additional frameworks, you can get that flexibility to move one application to the other application. And then they can intercommunicate using APIs or have VPN or use additional frameworks which provide that degree of abstraction.
Thanks, Mukesh, for that wonderful insight. I hope all of you are able to understand that area. Yeah, thanks. So
strongly encourage you to put in your feedback. If you need any additional topics, please put that in the feedback so we can plan for sessions for next year, what would be of interest to you. So if you don't put it in the feedback, some of this would get lost in the chat if you put in the chat request. So strongly encourage you to please fill out the feedback form as to what topics would be of interest to you.
So please take a minute out of your time and do fill up your feedback. That is very important going forward. And if there are no other questions, then I think we are good to proceed ahead. And
yeah, we'll do a quick 5-minute mind relaxation before we break off. But any questions so far, feel free to ask any question. We will be glad to share our experience, our insights as well. If not, we'll do a quick relaxation. So just like, we have containers which are elastic, the request comes in, if 1,000 requests comes in, we'll have 1,000 containers. Our mind it's similar, right? In this case, the request is nothing but the thoughts. Each thought comes in and we process those thoughts, right? So when too many thoughts come in, we feel stressed. And when we can space out the thoughts, we feel relaxed, right? So we practiced that last week. I don't know if you got a chance to practice it again as well, but we'll try to do the same thing where we want to space out our thoughts. The more the spacing out between the thoughts, where you're not doing anything, you're just observing. You are an observer, just observing. And when you do that, initially a lot more thoughts will come because the mind is not used to it. It is used to always processing some thoughts. So it doesn't find comfort in it. But with more practice, then it doesn't like anything when it's not in that state. So we find that relaxed state is more addicting. So what we want to do in the next few minutes is essentially just get into the practice of spacing out your thoughts, right? So step one, just observe the thoughts, right? So let's take a minute, right? And if there's no thought, that's great. If there are a lot of thoughts, just observe. Don't think on it. Don't add more to it, but just observe. Yeah. So let's do that. Let's practice it in 1 minute and just be an observer. Okay. Was everyone able to observe, or is the mind working too fast? Please feel free to put in your experience, right? Now the next step is if you just observing it, right? Uh, space it out, right? If there are a lot of thoughts one after the other, now what we want to do is we just want to space it out, right? And the way to do that is just experience that one thought, right? Just focus on one thought. And you can focus on one thought by just reiterating that one thought, right? Just being in the presence of one thought. And if that thought is a positive thought, it will be easier for you, right? So let's create a positive thought, right? That I am smart and I know a lot about cloud. That's also a positive thought because you're appreciating yourself, right? And just keep that thought and let's see if you can hold on to a minute. It's like holding on to a breath, but here you're not holding your breath, but you're holding on to a thought that, I am hardworking, I'm smart, I'm learning cloud. Positive, very simple to create it. I feel good about myself. So let's create that one thought and see if you can observe now that you can hold on to that thought. Okay. Was everyone able to do that? If you can acknowledge on the chat window, because this one small step that you can hold on to one thought, it could be a game changer. Was everyone able to experience it? Or there are still a lot of thoughts that are flooding the mind? Okay, great. Some of you are able to do that. Think of it this way, right? If you can stay in that one thought, that will show how much power you possess. It is not your mind that controls you. It is you who has the true control. This experience of just 1 minute can come in very handy when you're going through a stressful situation. Because how is stress defined? Abundance, too many thoughts rushing in and flooding your system, your mind, right? So all you have to do is step one, just observe it and then hold on to a positive thought. Now, many times we hold on to that thought by reiterating the thought, or we use a visual image to be able to associate our mind with that visual image. So our sense organ, our eyes are fixated on that image. So on your screen, you have an image. It's sometimes a lot easier to just say fixated on that image, but essentially what you're doing that by fixating yourself, you're focusing yourself on that image, you're trying to hold on to that one thought and not add more thoughts. That's why in a lot of other yoga or meditation techniques, they'll ask you to focus on an image. But essentially, the technique behind it is that you're trying to focus on one thought, right? So we want to focus on the thought level, because if you're in the middle of a meeting and it's a stressful situation where someone is saying something or anything, you don't have an image in front of you. The only image you have is an image of an angry person in front of you. And the more you fixate on it, it's very difficult to control. So that way, we want to make sure we are staying in that moment of that thought at the thought level, with or without image. We are in control of spacing out the thoughts. We are in control of being an observer. We are in control by reiterating that positive thought and being able to control our mind, right? So we'll do another, create another positive thought, right? That I am a peaceful, happy soul, right? And we'll just stay in that thought for a minute or two and we'll end the session, right? So I am a peaceful, happy soul. Just stay in that thought. I am a peaceful, happy soul, no matter what the circumstances around me. I am always peaceful and happy. I am peaceful and happy. This is a fact that I'm just realizing. I do not have to react, but just go inside and feel this peace. Spacing between the thoughts gives us a sense of silence. Silence is not just absence of sound. Inner silence is this spacing between the thoughts. More the spacing between the thoughts, the more we experience the inner silence. And the more we experience the inner silence, peace is natural. Okay, thank you very much. Hope you enjoyed this session. Please do practice these techniques. It'll just help you. The more you relax the mind, the faster it works. We don't have time today, but would be glad to share about the physics behind this as well. This comes under the realm of quantum physics, right? Where In normal physics, you have to give energy to do things and move it faster, right? Whereas in the mind, you give energy to slow it down, because when it slows down, it can take better decisions. It can think faster, right? So it's a fascinating way on how you can get most mileage of your mind, the power of the mind. It's phenomenal. So thank you very much for your participation. Please fill out the feedback, and we look forward to wrapping up this series next week and then starting with a new one. So thank you very much again. Have a great weekend or a great starting week.